In this video, we're looking at a random drawing package for a new construction bank, and we're going to do an example concrete takeoff. If you look at this isometric view, you can see how the structure is going to be built, and you get an idea of what the footings we will be taking off look like below grade. I'm basically just looking at the foundation plan here, noticing where they have tags to tell me which item in the schedule to refer to for the dimensions and reinforcing. I originally made a button in Revu to navigate back and forth from the foundation plan S01 to the footing schedule on the page before it, but I decided that was dumb, and instead I would just screenshot the schedule and drop it right onto the foundation plan so I could reference it whenever I needed to. When you use the screenshot tool in Revu, you click and drag out a rectangular window, and the contents of that window are copied to the clipboard. I can then navigate to the page I want and paste that image, resize it slightly to make it larger and easier to see. I also pull up the Properties tab and set the fill color to solid white so that it doesn't get lost in the title block material beneath. I realized for the wall footings, the majority are WF1, so I use the area markup and label it with the WF1 description from the schedule. I open the controls for which metrics to calculate, and check the boxes for volume and depth. I then use the drop-down to specify that I want volume measured in cubic yards to match concrete material quantity. Quick note, this probably would have been far easier to do with the Polyline perimeter tool and only taken off the length of the footings rather than the area, but I wanted to show how you can get volume and cubic yard calculations right in Revu by checking a couple boxes. The issue is that the area measurement doesn't give us an accurate length in lineal feet, but I ended up figuring it out later in Excel, as you'll see. Here I'm basically just tracing the outline of the footing shown as a dashed line and stopping it at the intermediate pier locations. This is because the continuous strip footings from WF1 meet the column footings at the same elevation, so to count them both individually is sort of doubling up on quantity. On this curved portion of footing and foundation wall, you see that I traced the footing of the radius separate from the straight wall. I'm not sure about where the footings tie in at their respective bottom of footing elevations, but I will mention that an alternative method of doing this would be to trace the outline of the straight footing along with the radius, and then using the Polyline cutout tool to trace the inside portion of the radius to remove that interior portion. Both methods of measurement will get the job done. This small section at the entrance lobby was a bit awkward to measure, and I probably should have returned the WF1 footing directly into the concrete pier, but by stretching out the length, I covered most of the area regardless. I finish all of the WF1 tag footings, so that markup is now finished. I pull up the window for the markups list. You can see the 7 or so instances of the area markups for WF1. I decided to separate the markups into layers for the purposes of this video because it's a good practice to do so when you have multiple trades, but it probably wasn't entirely necessary for the takeoff shown in this video. The one issue it does help with is the ability to turn off the visibility for specific markup groups. I will eventually do that later in the video when the drawing becomes tough to make out with all the annotations from the markups. One more note. I left the subject and label annotations long in this video to demonstrate exactly what the individual items were, but you can certainly keep those short so the drawing doesn't become a mess to read and navigate. I'm now going to repeat the same process for the WF2 footing locations. I'll enter the subject with the dimensions and reinforcing shown in the schedule, then use the drop-downs to include volume and depth calculations, and then change the volume measurement to cubic yards for concrete. If you're going to use the volume calculation, it's important to remember to enter the depth, or more accurately the thickness of the footing, so that the calculations come out accurately. When doing area takeoffs, I'll usually just pick various colors and turn the fill opacity down to 20 or 30% so you can see through them, but it's still clear which item is which. There is no rhyme or reason to the colors, at least in my case. One more quick note. If you find yourself using a markup often, you can click the toolbox icon on the left side. In the second window down, it will record your recent tools. You can right-click the icon for your markups and add that item to your tools to return to it, and continue using it whenever you want. The next item we're going to take off is the F4 column footing. We'll use the area markup and enter the details in subject, specify volume in cubic yards for concrete, pick a color for the fill, then scan the drawing for all of the tags that show F4 footings. In this case, it's pretty easy to see that most of the spread footings are this particular type, so I will go around the structure to make sure that I've got all the instances of F4 footings. When I finish, I select all of the instances of the F4 markup and specify that I want to create a new layer to add them to. This one will be foundation concrete, spread footings, and will include all three of the spread footing markups from the schedule. Next up is the F5 footings. These are the largest of the spread footings at 5 foot by 5 foot, and there are only 2 of them located in the center of the floor. Once I'm finished with those markups, I'll select them both and specify the layer as foundation concrete, spread footings. This process becomes pretty repetitive for the one remaining spread footing F3 by 5, and all 4 concrete pier types after that. We now have the final spread footing item, F3 by 5 footing, which there are 2 of at that entrance vestibule area. You can see that I accidentally chose a color that was too similar to the previous F5 markup, so I go back and change it to make it a little more noticeable. I then add those 2 markups to the foundation concrete spread footings layer, and I'm moving on to the 4 concrete pier types P1 through P4 as shown in the schedule. Again, the process for these piers is the same as the previous spread footing items. This is P1 footings. I will scan the structure to locate all the instances and mark them up. When finished, I'll select the instances in the markup list and create a new layer which we call foundation concrete piers. Repeat the process for P2 concrete piers. I didn't spend any time in this video explaining or even looking at the reasons for the multiple sizes of piers, but it is related to bearing capacity and size and height of the steel columns that sit on them. There was a schedule in the first couple pages with a lot of details on elevations of all the various structural columns. Another item that's relevant to concrete and would normally be included in this takeoff is the anchor bolts associated with those columns. One additional item that would typically be covered in the concrete are the foundation drains shown in that WF2 footing at 36 inches on center. Again, this video was not a thorough breakdown of every detail. It's more to illustrate some basic elements across the entirety of a scope of work within a project and how to take this data into Excel to generate your dollar value costs related specifically to your takeoff quantities. Next is the P3 concrete piers. As you can see, there are not many remaining on the plan. These markups will go quickly. When finished, I'll specify the layer and move on to the last pier type, P4. And finally, we've got the P4 piers, those two at the goofy vestibule area that probably holds up a canopy, if I remember correctly from looking at the isotropic view. I'll specify the layer, and the piers are now completed. The next set of takeoffs are the poured concrete foundation walls. You can see in the schedule they have the tag C8 for an 8-inch thick wall and C10 for a 10-inch thick wall. We use the Polyline tool to measure lineal feet of wall. These items are a bit more difficult to define because the height of the wall varies at different locations. The way to determine that is first to locate the symbol for bottom of footing, which is shown as a half circle and a dimension. The next call out to identify is the dimension shown in brackets along the foundation wall itself. This is the elevation of top of wall in relation to finished floor. The most common condition is bottom of footing at minus 48 inches and top of C8 foundation wall at 6 inches above grade. The WF footings are 12-inch thick, so that means the foundation wall begins at minus 36 inches and extends to 6 inches above finished floor, which equals a total height of 42 inches. There are a few locations where a C8 foundation wall extends to 24 inches above finished floor, which makes the total wall height 60 inches or 5 feet. At the door opening locations, the foundation walls terminate at -8 inches and the balance of that is filled in with the turned down slab to tie into the foundation. This gets a little tricky, but if you take your time to identify the various instances and changes in wall height, you can accurately account for every wall. The C10 foundation wall only occurs at that vestibule bump out location and terminates at -8 inches, and then it's got a C8 foundation wall on top of it. At this point, I felt that the drawing was getting difficult to navigate due to the annotations and multiple layers of markups. I first selected the C8 foundation wall at 42-inch height markups and assigned them to a new layer for concrete foundation walls. I then shut off the layers that contain the markups for the previous footings so that we can view the drawings more clearly. You can toggle the layer visibility on and off in the properties. You can see here that I briefly forgot how to toggle the layer visibility, but eventually figured out that you just click the eyeball icon to the left of the layer. Once I had only the foundation wall layer showing, I changed the property of the markups by increasing the thickness of the line, and I differentiated between various wall heights of C8 foundation wall with multiple colors. This helps to easily identify where the changes occur and to ensure that you haven't missed any portion of wall. I used the orange line to mark up the lineal feet of C8 wall that extended 2 feet above finished floor, so total wall height was 60-inch or 5 foot. This markup is for the C10 foundation wall. There was only this small portion at the vestibule area, as I previously mentioned. The final foundation wall markup is AC8 at the door opening locations, which had its own standard height at each of those instances. Once I completed those markups, the foundation walls are complete. Here I return back to all of the foundation wall markups of all C8 and C10 heights and assign them to the foundation wall layer. Once those markups are completed, I toggle the other layers back on so that all markups are again visible. The remaining takeoffs we need to complete for slab on grade and thickened slab will be done on the next page, which is the structural floor plan. Since we're working on a new page, I'll first set the scale to 1/4 inch equals 1 foot. I also copy the screen grab of the schedule from the foundation plan and paste it on the structural floor plan so that our dimension and reinforcing details are easily visible. The markups for slab on grade will be assigned to a new layer for slab on grade. I use the area tool to trace the perimeter of the building for the 5-inch slab on grade. I include in the subject that it calls for welded wire reinforcing, 6 mm vapor barrier, and 8-inch of stone base subgrade. Since the area of the slab is the same as the area required for those items, we can simply copy that square footage figure and apply it to individual components of the slab on grade assembly if we choose to do so. I make sure to check the volume and cubic yard options to calculate the cubic yards of concrete necessary for the slab. For the thickened slab at perimeter foundation walls, I use the Polyline tool and assign the depth to 8-inch thick and width to 12 wide per the detail on a previous page. Once those markups are completed and assigned to the slab on grade layer, we have completed all of the takeoff included in this video, and we will export our markup quantities to a CSV file that we can adjust to our spreadsheet structure in Excel. Side note, I realize that those columns are showing a detail for some type of thickened slab and/or connection with the piers. I chose not to go into that level of detail, so I traced the slab as if they were not any different. I wanted to point out that if this were a detailed takeoff that would be used to quote the labor and material on a real job, this is not something that could be overlooked, and you'd need to include it with all your other markups. This is our final markup for thickened slab, which I included only at the perimeter walls because I happened to read the note and detail on a previous page. This condition would exist at several other areas on the plan, but we are not including those for the purposes of this video. In the markup list, I open up the column options and select the columns that I'd like to have displayed and turn off those that won't be used for anything. This is all in an effort to export our markup data in the most efficient way. I would argue that I didn't do a great job of this, as you'll see when we're formatting the Excel spreadsheet, but by leaving the entire process in for you to watch and creating the structure from scratch, I believe it will help you gain an understanding of how you can manipulate the data and metrics to customize your Excel own sheets, which are calibrated to your own common work items. I'm going through the markup list and making sure everything is grouped correctly, deleting erroneous elements such as the screen grabs of the schedules and an area measurement I had taken on the floor plan to get the square footage originally. Once we're ready to export, I click the icon in the markup list and select CSV Summary. The first tab has you toggle on and off the columns you want included in the report. The middle tab has a filter and sort preference at the bottom. We want to select to group markups by subject so that all instances in a markup group stay together. The final tab is where we want to save the Excel document and options for how much detail to include. We went with both the markups and summary, although we eventually end up condensing them back into single item headings for each markup group. You'll see this play out when we move over to Excel. Now that we're working in Excel with our markup quantity data, I first expanded the column widths so I could read the data. I eliminated a few columns right from the start that I identified as useless. Since the data is brought into Excel without any formatting, the first objective is to identify the markup group headings and delineate where the groups start and the next begins. I did this by highlighting the group heading in green. The result is the markup group heading shown at the top of each group with the totals across the column data, and underneath those headings are the individual markups in their own rows. I wanted to keep the groups intact, but also create a tier within them, so I inserted a column to the right of the heading subject line and moved the individual markup subjects into the new column. I determined the next important task was to take each group item individually and identify the critical metric for each one that I would eventually use to assign a cost value to. This is what you're watching as I'm going down the list and highlighting a measurement and unit in yellow. Now that I've got a rough idea of the relevant data and each group item, I determined that the column layout was no good for where I needed to end up, so I created a new sheet to start fresh. The idea is that I now have the data somewhat organized, and I can design a format that will display the data in an effective way. I select the group heading descriptions one at a time and copy and paste into the new sheet. I wanted to add a column to number the group items in a list, so I inserted a column for that to the left of the pasted group subject line. I entered the numbers 1 through 16 to correspond to the quantity of group items from our markup data. So the columns are now A equals work item number, B equals work item description. I go on to add those relevant quantity metrics for each work item into the C, D, and E columns in no particular order, only to accommodate the current work item that I'm dealing with. This will eventually give us a more condensed and precise list of work items and their metrics, but it's unorganized by default since they require different values and metrics to assign a value. For this reason, we will eventually transfer this new condensed version of the data into one final new sheet for a layout revision and clean it up. For our second work item, which is one of the C8 foundation wall takeoffs, we need to insert a formula to calculate the cubic yards of concrete because our takeoff measurement was lineal feet with the Polyline tool in Revu. Our relevant metrics on this item are length, height, and width, or more accurately wall thickness for this item. We pull our length number from the original sheet. The height figure is identified right in the item subject line, as we called out the different instances of C8 foundation wall heights. The width of all the C8 foundation walls is 8-inch thick. To convert these metrics into cubic yards, the formula is length times height times thickness, which gives you the cubic feet, and you divide that number by 27 to convert to cubic yards. The problem is that this formula conversion assumes the inputs for length, height, and thickness are in feet, not inches. Our height and thickness data is currently in inches. A quick fix for this issue is to change the inputs to a formula to divide the inches by 12. In Excel, you'll enter the formula, equals 42 divided by 12. This will return the height of the wall in terms of feet, in decimals. Our 42-inch wall height becomes 3.5 feet. Repeat this process for the width of the wall, and enter into the cell, equals 8 divided by 12. This returns 0.667. Now we can enter the cubic yard formula in column E, which is equals F3 for length of item 2, times G3, which is height of item 2, times H3, which is thickness of item 2, divided by 27. This will return the cubic yards of concrete. As you can see, I'm continuing to go item by item down the list, copy and pasting from our original sheet, and then inputting the takeoff data measurements, and assessing how to convert that item into the unit I want to apply a dollar figure unit cost to. In most cases, that metric is cubic yards of concrete in this particular example. Normally, my spreadsheet would be much more detailed and incorporate cost component breakdowns to take into account labor, material, equipment, and subcontractor costs associated with each individual item. In this example, we are only using an assembly unit cost average to get the work item totals individually. The goal of this working sheet in progress is to have the condensed data expressed in terms of the unit that we will multiply by the assembly unit cost in our final layout in the next sheet. You are watching that process unfold down the list for each item in preparation for the finished sheet structure. I realized as I was working my way through the list that some of the items require me to input a quantity figure for the count of instances of that item, which then interacts with a formula based on the material associated with one unit of that item, which then converts to cubic yards of concrete. For this reason, I inserted a column called count, and because our takeoff groups include the number of instances within that markup group in parenthesis at the end of the description, I can simply enter that figure into the count column, and the formulas do the work for me based on how many there are. When you are doing these types of conversions to structure your spreadsheet data, it often serves as a double check where you can reverse the formulas to confirm your data is accurate. I do this frequently as I'm working my way through the list. On this particular item, I was having difficulty with the quantities not matching through the conversion process. I knew there was an error, and it took me a minute to figure it out. If you recall from the work in Bluebeam, I mentioned that taking off-the-wall footings with the area tool made it more complicated because I didn't have the quantity for lineal feet. I eventually worked this out and got the data to match up and continued down the list. We finally reach the end. All of our work items are converted to the units we need them in, and we can create our final sheet layout. I did not record the process of the column layout for our final sheet, but you'll see as I transfer the data from this second condensed sheet to the final sheet how everything functions. Just as with the second sheet, I perform backup checks along the way to check for errors, and everything matches up as it should. When I input the data from the second sheet, the line total is generated for each item. The layout is way cleaner, and it allows for us to generate further more detailed metrics if we choose to. This layout also provides a very easy format to come in later and adjust the assembly unit cost, but all of the formulas still calculate accurately, and the costs are instantly updated to reflect the change. Just as an example for what a detailed version may look like, on the first item, slab on grade, I included the various components that make up the slab on grade assembly unit cost as their own rows. Ultimately, I combined them all in a single unit cost row and continued that way for the rest of the work items. But you see how the level of detail you want to break it down to is easily accomplished. This final layout has a few added features, such as waste factor for material, which I set to a default across the board as 10%. The CY concrete figure is first multiplied by the waste factor to generate a material subtotal. That subtotal is then multiplied by our assembly unit cost for that item, shown in the column highlighted green. Another added feature is the markup column. This feature performs the function of adding a profit margin to each work item. I used 15% as a standard for all items. The material subtotal is multiplied by the assembly unit cost for a line item subtotal, which is then multiplied by 1.15 to add the profit margin, and the line total column is generated to include that markup. There are endless features you can incorporate into a system like this. You can customize them any way you'd like to reflect the needs of your work. You can see how much more quickly the process goes when the layout is structured in a way that accommodates your takeoff data. It took us a while and several iterations to reach this point, but now that we've got it formatted this way, it's as easy as inputting a few data points, and the formulas calculate instantly to provide us with more data and insight in an organized format. Side note, because we've taken the time to prepare this structure, we can use this sheet as a template for future jobs and continue to refine the layout and design to automate the process further. Here's an example. Suppose you bid another job a week from now, and that project contains several work items similar to what we have here. Even if the components are different, the structure you've built allows for you to make minor adjustments. But you can essentially copy and paste a line item here into a new sheet with all the formulas and functionality, and it will remain accurate for the new work items. This is a big part of why so many estimators refuse to adopt expensive estimating platforms. None of them provide you with the flexibility and customization of building your own spreadsheet in Excel. We've got all of our line items entered and totaled out individually. You'll notice I added a subtotal at the bottom. This cell simply contains a function that adds up all of the individual line item totals from the far right column and returns the sum. Below that, I added a row for general conditions. In this example, we are not going into detail on what those costs usually are, but I provided it here so that our final result looks more like an actual bid. The same principle goes for the line beneath that, the overhead figure. For these two rows, I input a random figure that seemed proportionate to the job and our subtotal to this point. Finally, I added a final total beneath that which contains the function to sum these three rows. Once we have that final total, we can look back at our data and create some additional functions to generate more detail. For example, I added a cell that sums the cubic yards of concrete for all line items. I then input a dollar value figure for a cubic yard of concrete material. I created a label for a row called material. That figure is the total cubic yards of concrete times the unit cost dollar value of 1 yard of concrete on average. Below that, I created a label for a labor dollar amount, but left it blank. Below that, I created a label for other costs. The formula for other costs was the sum of the general conditions figure plus the overhead figure. I then returned to the labor item and input the formula equals final cost minus material cost minus other costs, and that returns the remaining dollar value from our total with materials and other costs removed. I wouldn't recommend this as an actual method to calculate labor costs, but you can see how a simple equation gives you the ability to look deeper at these metrics in any way you choose and present that data in an organized dashboard. Just as a point of reference, I took the takeoff quantities and asked ChatGPT if my line item cost detail was consistent with current costs. I do not actually believe Al has the ability to give me an accurate response to that question, at least not one that's based on anything tangible, but I can say that when reviewing the cost breakdown, it found that all of my line item cost totals were consistent with the exception of one minor footing item that was within the range but on the high side. I am a big believer in knowing the job and all the details to provide an accurate estimate. But this is an anecdote that even at this basic level of unit cost averages, the number we ended up at was well within the ballpark and closer than I imagined it would be. Hopefully, you learned something by watching this video, and I wish you the best with developing your own platforms. If you're new to this, you'll find that it's a never-ending pursuit to create the perfect spreadsheet. Have fun with it.